Hey guys, welcome back to another paper. So here we're looking at the Maths A paper 4HR, and this is from the June 2016 session. So without further ado, let's go straight into paper. Okay, so this will be, of course, the complete walkthrough and breakthrough every single question. And just to make it clear, you're given the formulas for everything, literally everything, for the high tier and possibly the foundation tier as well. You're given Pythagoras' theorem, trigonometry, volume of cones, curved surface area, spheres, pretty much the whole set, an area of triangles, the sine and cosine rule, and of course the area of trapezium as well as the cylinder rules. And the most important one is the quadratic formula. So make sure you guys got this nailed down. Alright, so let's do this. Let's have a go. Now, what do we have here? So question 1. Here we have to answer all 21 questions. So here, this will include all 21 questions. Right, number 1. So it looks like we're doing transformations here. So A, enlarge shape S by a scale factor of 2 from center 1, 1. And then label the shape T. Okay, so just looking over here for a second. The one thing you must have is firstly a ruler, okay? I'm not going to use a ruler because this app unfortunately doesn't have straight lines. So the key idea is to always, from the center, try and draw a dotted line all the way up to the corner you want. So a straight line, and count the blocks, and then just keep extending the line across. So it should look something like this. Not as bent as mine, but you see how it goes. So perfect straight line, and then you do the same for another corner. Say here. So you just do. And then if you're doing it freehand, you should try and count the blocks. So 3 across 2 up, 3 across 2 up. So my next one will be here. My next one will be here. Okay, so anyways, you keep doing this and then you should be able to kind of figure out where the enlargement is. So we see that this shape is going to be doubled across. So you can see it's moved 2 across, meaning it needs to move 4 up. So the new position will be here. So you just have to count. So double, once across, twice across. This one, once across, twice across. So the new position will also be here. So the base would be something like this. Now for this position here, well, it goes once up here, so it's going to go twice up here. And then you can kind of figure out the rest. So it goes once across, so it must go twice across. Now just connect the dots. And that's it, guys. That's literally how you pretty much enlarge something. This is just doing it a freehand method. The key idea is to probably draw 4 lines, so 1 across every single point. So even across this point here and this point here, until you intersect everything. Anyway, let's keep going. So B, describe fully the transformation that maps shape T onto S. Okay, so actually they pretty much want us to figure out how you describe going from T to S. So going from S to T, you're doubling it. So clearly going from T to S, you're halving it, or a scale factor of half. So we could say enlarge, or delarge really, enlarge shape T by a scale factor of half from center 1, 1 onto shape S. I mean, you could also say this is a transformation. The transformation is an enlargement from T to S by a scale factor of half from center 1, 1. Various ways to say it, as long as you get all the key points. Alright, let's go, guys. Okay, question 2. So these ones are one of my favorites when it comes to algebra. So solve 6t minus 5 equals 2t plus 9 and then show clear algebraic working. Okay, so all you have to really do is pretty much knock every t onto one side and non-t's on the other side. So we got 6t and 2t here. So what we could do is subtract 2t on both sides. So this becomes nothing and this becomes a 4t. And add 5 to both sides. So this cancels out and this becomes a plus 14. So therefore we have 4t equals positive 14. And then to separate, to isolate the 4 from t, just divide it by 4. So t equals 14 over 4. And simplifying this, or divided by 2, you should get 7 over 2. And that's it, that's your t value, 7 over 2. Okay. Part B, expand and simplify the following. Okay, cool, not too bad. So we'll just multiply the first set of brackets by 3, so you should get 6y plus 6. And multiply the second by 2, so you get 2y minus 8. Add them up, so 6y plus 2y is 8y. 6 take away 8 is negative 2. Cool, man. So easy. Alright, simplify fully. Alright, so we've got 4wxy divided by 8xy. Okay, so first thing you'll notice is that you don't really need to worry about the bracket. The bracket just means that everything has to be locked inside. And to do this, when I divide, I always flip as a fraction. So it's going to be 4wxy over 8xy. Now let's change color of the pen. I'm going to choose this one, purple. And let's start knocking out common terms. So we've got xy, they can both go. So we're left with 4w over 8. Now, number terms, well, you can see they're both in the 4 times table. So divide them both by 4, you're left with 1 and 2. So we're left with 1w over 2. But in maths, we don't need to put the 1, so it's just w over 2. And that's it. The solution is w over 2. Okay, moving on. Question 3. Let me get back my other pens. So, there were 2.1 million people living in Dubai in 2013. 1.75 million of these people were not born in Dubai. So it goes to show Dubai is a really hot place for expats, isn't it? Hey, work out 1.75 as a percentage of 2.1. Oh, this is easy. So as a percentage, work out, it just literally tells you what to do. So 1.75 over 2.1, and as a percentage, just multiply by 100. Smash this in your calculator, and you should get 0.1 times 100. And then press the SD button or a conversion button, and you should get 8.333 or 83.3%. So easy. So this is one of those easy marks. Okay, next one. The unit of currency in Dubai is the dirham or dirham. The exchange rate is £1 equals 5.52 dirham. The cost of a pair of running shoes in Dubai is 343 dirham. The cost of an identical pair is £54.99. So which is better priced? The pair of running shoes is more expensive in Dubai than UK. But how much more expensive? Give your answer to the nearest dirham. Okay, so main point here is to convert pounds into dirham, yeah? So we know that for every pound you get 5.52. That means for £54.99 we need to multiply this by 5.52. So let me just write that here. Okay, what does it give us? Okay, to the nearest dirham, so just round it to the nearest whole number basically. 0.99 times 5.52. And you should get to the nearest dirham 304. So it should be 303.5, but round it up. So it's basically expensive by, and then you just do 443 minus 304. It's expensive by 39. The difference is 39. Get a lot of marks for that as well. A plane flies a distance of 5,520 kilometers from London to Abu Dhabi in 7 hours and 24 minutes. That's quite good. What could average speed of a plane? Well, you just use the speed distance formula. So speed equals distance over time. And we're measuring it in hours, so it's going to be 5,522. And then the distance is going to be, oh yeah, because you got minutes, well, we got to rewrite that. It's going to be, firstly, 7 plus, and then treat this as a fraction, 24 over 60. And you can just put that in your calculator and get a mixed decimal answer. 7.4 hours. So this is exactly how you convert. Anything you have, flip as a fraction, yeah? So we just divide it by 74 this part, and we should get, what is it, to 3 7 figures. It's traveling at 746 kilometers per hour. Quite fast, quite fast. All right, number 4. Here is a kite, A, B, C, D. Okay, so one property you need to know about kites is that they have identical angles at some points. Yeah? So this part would be considered an isosceles if you were to split this in half. So hence this would be also 111 degrees, meaning instantly we can work out this angle by summing all the interior angles, which add up to 360 by the way, because it's 4-sided, and we can work out this one. So work out sides the angle ABC. Oh, there we go. That's exactly what we need to do. So find this angle here. So in your calculator, just pretty much add up these sides. So 90 plus 111 plus extra 111, and then subtract that from 360. So let's do that. 90 plus 222. So I got 312, and then minus it from 360, you should get 48 degrees. Simple. So let's put 48 here. Okay, part B. Let's check it out. So two of these kites are arranged so that the shorter side of one of the kites is placed on top of the shorter side of the other kite, as shown below. So these are the same kites, by the way. They're both ABCD kites. So just to make it clear, I think it's best we just label it right now. So cut down a few steps. So 48 degrees. We know this whole one here is 111. And this one's also 111, but it's been split by 19x, meaning 90 plus x is 111. Therefore, if you subtract 90, you should just get 21. So this is 21 degrees. Okay, let's keep going. So work outside angle x. Okay, we did that. It's 21 degrees. Work out sides of y. Okay, so let's keep going. So we need to figure out what this one is. So we should know the value of this angle here, I believe. We have it previously, right? 111, yeah. Because it's just been rotated, it's still the same size. So this angle must also be 111. And one thing to know is that this shape here is actually a pentagon. So it's a 5-sided shape. So if you don't know the sum of the interior angles of a pentagon, we could always use this formula here, which is n, the number size, minus 2 times 180 will give you the exact number, total and number of angles inside or the sum of all the interior angles of any polygon. So pentagon is 5-sided, so n is 5, so it'll be 5 minus 2 is 3, times 180 should give us, I think it's 540, yep, 540 degrees. This means that all of these must add up to 540. So we can just subtract it from 540. So we've got 90, 90, 100, 111 equals plus y equals 540. So we've got 90, 2 lots of those, so twice, plus 2 lots of 111 plus y equals 540 degrees. If you add up all of these ones, we've got 2 times 90 plus 2 times 111. So I'll go 402 degrees here, plus y. Subtract 402 from 540, and you should get 138 degrees. Okay, so here we need to complete the table values for this quadratic equation, okay? So if you guys don't know, a quadratic equation is always in the form of ax, always in the form of something x squared plus an x plus a constant, and this is exactly what it is. So it's quadratic. Now, this is dead easy. You're given a table, just pop in the values of x to get the respective y. For example, if you pop in minus 1, you should get minus 1 squared. So, actually, no, just put this in the calculator. If you want to put in the calculator, right in this form. So, y equals bracket minus 1 squared minus 4, bracket minus 1 plus 2. Always replace the numbers in brackets, so to avoid any errors. Now, let's do that. So, have a go at each one and see what answers you get. I believe because this should be symmetrical, you should get similar answers up below. So anyway, I got 7 here. If I plugged in 1 squared minus 4 plus 2 is minus 1. And lastly, if you put in 2 squared times 2 is minus 2. Now, I'll just do the rest. So this one should be 7, I believe. I'll double check that. Yep, 7. So because it's a quadratic graph, it's going to be a U shape, and it's because it's U shape, it will be symmetrical from this point here. So on the left side, on the right side, you should get the same values. If I went up to 6, then it'll be 14 here. All right, on the grid, draw the graph of y equals x squared minus 4x plus 2 for the values of x from this range, meaning plot all of these in from minus 2 to 5, all of these values too. So let's try it. So from minus 2, we have 14. So minus 2, 14. Let's try and be accurate. So this is not going to be the best one, but close enough. Minus 1, 7 is here. And then 0, 2, easy. So here, which is probably the least accurate one of them all I did. 1 minus 1, which is bang in the center here. Okay, so this is where the turning point is. 2 minus 2. Okay, so look, yeah, this is the turning point. So now it's just going to be symmetrical. So 3 minus 1, 4, 2, 5, 7, and of course 6 here. Well, you don't actually supposed to draw that one, but for the sake of completion, I'm just going to do it. Now you just have to connect the dots. So this is the hard part. So freehand always kind of sucks. Okay, so it's gonna be tricky now. Oh god, that was awful. Okay, seriously, I need like some kind of app which will just link these together. Oh my god. So try and make it as smooth as possible. Yeah, so really smooth. Okay, has to be super smooth. Anyway, the point K4, where k is greater than 0, lies on the graph or y equals x squared minus 4x plus 2. Use the graph to find an estimate for the value k. So basically, if it's on this graph, we know the y coordinate is 4, which is what, here, and you go find this k value. So what I would do, change the color of my pen. In your case, I'll just use black. You just draw a line that cuts through y and then see what points it hits on the line. So it hits around here and around here. So as an estimate, what's the x value and y is 4? Well, if you just draw it downwards, it should be around here, which is what, 4.2, 4. It's going up on 0.2s, isn't it? It could be, this one's about, let's say 3, 4. So that's 4. X is 4.3, and over here that's about minus 0.3. X is minus 0.3, comma 4. So use graph to find estimate of k, and we know that k is positive, so it's not going to be the negative value. It's obviously going to be the positive 4.3. So I think the answer is 4.3. Okay, it's about this. So as long as your curve is very accurate and you just really zoom in, you should get an accurate answer. It might not even be 4.3, but you get the idea. Let's go. Okay, here is a list of numbers written in order of size. You've got 3, 6, x, y. So it seems to be going up. Well, in any order. We don't know if it's arithmetic or not. We know that the numbers have a median of 8. This means that the middle number here has a median of 8. So the difference between these two is halfway. Between 6 and something is 8. So we can figure that out. If it's 6 to 8, that means this must be a 10. Because halfway between 6 and 10 is 8. It also has a mean of 11. So that means the sum of all these numbers divided by the number of numbers, which is 4, must equal 11. So 3 plus 6 plus, now we know it's 10, plus y all over 4 must be 11. That means if you solve this algebraically, 3 plus 6 plus 10 is 19. So 19 plus y over 4 must equal 11. Multiplying 4 across, so you get 19 plus y equals 44. And subtracting 19, therefore 44, take away 19 is 25. So therefore, and also x we said was 10. And that's it, guys. Here is your answers, 10 and 25. Very easy actually, isn't it? So these kind of questions are actually quite easy. Let's go. Number 7, here are two circles. So it seems to me we've got like a nice donut shaped one. One has a radius of 3 and one has a radius of 2. So the biggest radius is obviously 5 if you're going to go through the whole thing. Okay, so same information as I just said. Work out the area of the shaded region. Oh, easy. Very easy. So the way to look at this is to think of it this way. Find the area of the smaller circle and find the area of the big circle and then subtract it from the little one. Then you got the leftover, which is the donut. So the small area, let's just say it's 3 like I said. And the area of a circle, if we're not sure, is pi r squared. Useful formula. So we could say to find the shaded area, this is going to equal the area of the whole circle. So pi, the radius is 5 squared, minus the smaller circle, the inner one, pi r squared, when the radius is 3. You should just put this in your calculator. So I'll do it now. 5 squared minus pi 3 squared. And I got 16 pi, which seems legit. but they want 3 significant figures, so 50.3 is your answer. So that should give you the region of this part. So remember, I combine the radiuses. So you need to find it from the center of the circle to the end, which is 5 centimeters. That'll give you the area of every single part of the circle. Okay? Alright, not bad. So Luis makes a model of a plane. The wingspan of the model is 50 centimeters, whereas of the real plane is 80 meters. So it's combining. So for every model, 50 centimeters is equivalent to 80 meters. So let's put here. So 50 to 80. And this is from the model to the real. So the actual real design, the real specifications in real world design. Work out the scale of the model. Give your answer from 1 to n. So basically find one unit. So to get from 50 to 1, you divide by 50, right? So that means dividing both sides by 50. So 80 over 50 gives you 1.6. So for every centimeter, you get 1.6 meters basically. Quite easy. The length of the real plane is actually 72 meters. Work out the length of the model. So again, using this ratio, so 50 to 80, we know that the 50 to 80, we know that the real model is 72. So we need to somehow find this equivalent. Well, it's hard to just jump from 80 to 72 to divide, so it's always easy to find a single unit, which is dividing by 80 to get to 1. So dividing 50 by 80 is, well, let's just say 50 over 80. And then to get 72, well, just multiply up by 72. So in your calculator, it's 50 over 80 times 72, which will give you a nice 45 centimeters. And this looks about right. So the actual length of the model is 45 centimeters. Sweet, easy. Moving on. So there are 30 apples in a box. The mean weight of these 30 apples is 120 grams. Okay, let's keep that as a mental note. There are 10 apples in a bag. The mean weight of these 10 apples is 95 grams. Oh, so you can see the average weight is obviously much greater. Doesn't mean there's just because more apples, it's just coincidence, I guess. Work out the mean weight of 40 apples. Right, so the way this is running is that we actually need to use what's it called, the weighted mean average for all apples. So for the 30 apples, there's a weight of 120 grams, and for the 10 apples, there's a weight of 95 grams. We need to divide all of this by the total number of apples, which is 40, and this will give us our weighted average. So it's always the mean of one number plus the mean of a number over the complete total average, which will give us our final one. So put this in the calculator. What do you get? So 30 times 120 plus 10 times 95 over, and that's it. I got 113.75. 113.75. Yep, seems legit. It has to fall between actually. And yeah, 113.75 grams. Okay, hope that's clear. Alright, question 10. Solve these pair of simultaneous equations. Right. So you're given the standard linear ones. The way to make this work is to always make either the coefficients the same or make one the subject. I'm going to make coefficients the same. Yeah, so I'm going to make the values in front of the x the same. One's 4, one's 3. And we need to know that the lowest common multiple between these numbers is 12. So to get this to 12, multiply these by 3, and multiply these lot by 4 to get 12x's. So from the first equation, times in the whole set by 3, you got 12x plus 9y equals 18. Second equation, times by 4, 12x plus 20y equals negative 4. Now all you want to do is subtract. 12x take away 12x is gone. 9 take away 20 is minus 11y. 18 minus 4, so it becomes positive. 18 plus 4 is 22. So dividing negative 11, you got 22 over minus 11, which is minus 2. And that's it, you solve for y. As for x, well, plug it back into an equation. So let's say, which is easier? I'm going to pick the first one. So plug in y into here, substitute y into the first one. So you got 4x plus 3y equals 6. Plug in y back in, so you got 4x. So 3 times minus 2 is minus 6 equals 6. So make x a subject, so add 6 on both sides, so this cancels out and this becomes a 12. So 4x equals 12. Then dividing by 4, you get x equals 3. Of course, y is -2. Yeah, so I hope this helped, and let's move on to the next one. Right, question 11. So here is a triangle QRS. Okay, so we're given a length of 15, an angle of 90 degrees, which is here, right angle, and the area of the triangle is 60 centimeters squared. So let me just write inside 60 centimeters squared. Work out the size of angle SQR. So SQR, so this angle here, I'm going to call it theta, yeah? Give your answers correct to 1 decimal place. It looks quite easy. It just looks like a typical trig question, doesn't it? So how are we going to go through this? Well, let's make a plan. So we got the hypotenuse, which is this side firstly, and this is a right angle triangle. So trigonometry has to be used here, but we're also given an area. And if you remember, the area of a triangle is always given to be half AB sine C. This is in the front of the book, so you can double check that. And the way this works, for any triangle, you got length A and length B and the angle between, which is C, from any corner. So what we need to do is find, and because we know the area is 60, we can find the length in between. So let's use sine 90 as the base. So we can find out this length here, x. So this means letting 15 be A and x be B, and then C be theta, we're going to have the area, which is half times 15 times x sine 90, and this must equal 60 centimeters squared. So now we can solve for x. So putting this in the calculator, so we're going to have divide half 15 sine 90 across, we're going to have x equals 60 over half times 15 sine 90. You should get, let's have a look, 60 over 0.5 times 8. So I got 8. Okay, just checking that looks okay. Yep, looks like an 8. So therefore, the new triangles, I would always redraw it. I'm going to make it look a bit more flat. So 15 across here, 8 across here, and we're trying to find this angle here, theta. Now we can work this out using trigonometry. So what do we have? So if this side was a hypotenuse, we can say that firstly from trigonometry, from SOHCAHTOA, well, we have firstly this is the angle of interest, theta. So this 8 is the opposite, and this one here is the adjacent. So we need O and A. So we need TOA. So we can say that tan theta equals opposite over adjacent. And that's it, guys. Now all you do is literally tan inverse this, and you get your answer. So theta equals the tan inverse of 8 over 15. Let's try it out. Tan inverse. And you should get 28.1 degrees. And that's it. That seems to be all you have to do. Oh, so it's quite tricky actually. I'm looking at it carefully. You're given area triangle, so you have to make sure you use it and then figure out that we can work this using some kind of trig. And that really looks about it, that, doesn't it? So let's move on. So the table gives some information about the incomes, £pounds of 100 people in the UK. Right. So we're given the amount of money. So for 12 people, they earn under £10,000, whereas 41 people earn between 10 and 20k. Seems about right. So it seems to be that the bulk of people earn about this amount of money. That is actually real life standards, whereas only very few people earn over 50k up to 60k. Right. Part A, complete the cumulative frequency table. So we want to see how much, people earn as a total up to 20k, 30k, and so on. So the way cumulative works, you just literally add and go. So up to 10k, clearly 12 people earned it, but up to 20k, we can see that it's a total of 12 and 41 people. So that's 53. 53. Oops. Okay, and then to do the rest, you just add and go. So 53 at the next amount up to 30k is 25. So 53 plus 25 is 80. Oh god, 78. I meant to say. Next amount, add 12 to 78. You should get 90. Add 6 is 96. and then add 4 is 100. That's correct, because you start with 100 people and you must have a total amount of 100. Okay. Now draw on the grid, draw a cumulative frequency graph for your table. Easy. So we just have to draw this out. So draw the corners. So we always start from firstly the bottom left corner, which is 0, 0, because basically nobody's earning nothing. Unless but then there's also the benefit scheme. But in this case, we assume nobody's earning nothing. So up to 12 people, they're earning 10k. So 12 people is around here. So going up in twos earns 10k. So 10k, there's 12 people. So you just plot, like some use the coordinates. 53 people earn up to 20k. So 20k, 53. So this is 30, 40, 50, 52, 53. Next one, 78 people earn up to 30k. So 30k is about 70. So 80 is here. So it's one back. Yep, that's about right. Next one is 90 and up to 40k. So this is where the bulk of the people lie, or the remainder of the people, I should say. So it's going to be very small here, small dip. 96 is up to 50k. So 50k is this thick line here. 50k, 96, 100 is here, 98, 96, and of course, everyone should be at 100k. That's it. I mean 60k. The rest of the book's at 100. It's at 60k. Now all we have to do is just connect it and draw a smooth curve. So just like, oh no. Yeah, don't worry what happened there. So just try and draw a smooth curve. So yep. Not that smooth, but it's really hard to draw a smooth curve. So it has to basically dip, but yeah. So the kind of curve we're looking at is something like this. Yeah, that's kind of the kind of shape you're expecting. This means that majority people are around here, but then very few at the top and very few at the bottom. Okay. Now C. Use your graph to find an estimate for the median. Well, the median is the middle amount of people, so the 50th person from the 100. So we draw a straight line here, and we link it here. So we can see that this person here represents how much money exactly? Well, here. And that's going up. So that's 10k, 20k, 15k. So going up in 1k's. So that'll be 19k. So it's 19,000. Whereas the interquartile range is the difference between the third and the first quartile. So there's 100 people. The third quarter is 75, whereas the first quarter is 15. I'll just link them down. So this seems to be bang over here, whereas this is around here. So dipping it downwards, that falls all the way around here, am I right? And then this one is about here, so it's 15k. This is 25, 6, 7k. So 15 and 27, the difference between 27 and 15. So that's 12k. Yeah, so the interquartile range, so the difference between the 25th and 75th person is by 12k. So that's actually quite a lot. That's actually quite a lot. Anyways, that's it for interquartile range. So let's move on. Okay, question 13. So write 250,000 in standard form. All right, I love this kind of question. These are actually really easy. So you just count how many numbers are after the first digit. So there's 5 numbers. So it's just gonna be 2.5 times 10 to the power of how many digits? 5. Easy. That's standard form for you. Now the radius of the planet of Jupiter is 6.99 times 10 to the power 7 meters. The radius of the Earth is 6.37 times 10 to the power 6. So the radius of Jupiter is far bigger, basically. Anything with the higher power means it's far bigger. The volume of Jupiter is k times the volume of Earth. Okay, assuming that both planets are spheres, which they're not, but let's assume, calculate the value of k. Alright guys, so let's try this out, yeah? So this means that Jupiter is bigger than Earth. So we can say that the volume of Jupiter equals k times the volume of Earth. That means the scale factor k is the Jupiter over Earth. So Vj over the volume of Earth. Now, in the formula sheet in the back, you're given the volume of a sphere formula, which is something like this. So the volume of a sphere is 4/3 pi r cube, but r is the radius. Now, they have the same formula, thankfully. The only difference is their radiuses. So we're going to have to replace r with the Jupiter's and r of the Earth's. So Jupiter's radius, so it would be 4/3 times pi, bracket, and the radius is 6.99 times 10 to the power 7, all cubed, over Earth's, which is 4/3 pi, times its radius, which is 6.37 times 10 to the power 6, cubed. That's it. Now, all you have to do is really just punch this in the calculator. So let's do that, yeah? You can actually ignore the 4/3 pi because in fact they cancel out. But anyways, just to be safe, I'll copy anyway. 0.99 times 10 to the power of 7. So that's 7. Looks like a 4, doesn't it? Cubed. Over. Make sure you put the brackets here. The brackets is very important to put down. Times 10 to the power 6 cubed. And whoa, that's big. Give you answer freezing figures. And I got about, what did I get exactly? 1,321.335. The free simple figures is just the first three numbers with rest zeros. So 1, 3, 2, 0. So 1,320. Whoa, that's actually massive. So you could fit 1,320 Earths into Jupiter, basically. Oh, that's a lot. Okay, number 14. Solve this equation. Oh, this is easy. So when you have fractions, the first rule of solving any equations is to get rid of the fractions. So we need to multiply everything by 4. So this cancels, and this becomes an 8. So we're left with 8y plus 2 minus 3y equals 1. Now collect the y's. 8y minus 3y is 5y. Subtract 2, so this becomes a -1, so equals -1. And then divided by 5. So y equals -1 over 5. That's it. So minus a fifth. Part B. So factorize this quadratic. Ooh. So this one has a 3 in front. So when you got numbers like this, it's always more tricky. So the first step you want to do is put a double bracket, one with 3x, one with x, to guarantee that 3x and x makes 3x squared. Now we need two numbers to make 3. It has a product of 3, so obviously it's 1 and 3, because I think that's the only two numbers you can possibly have. And it has a difference of 8. Well, something you need to multiply one of these by 3. So you got to pick one number to multiply by 3 and then subtract it against the other one to get 8. So let's pick 3. Let's do 3 times 3 here. This will give you a 9, and 9 and 1 has a difference of 8. So yes, if you put 3 here, 3 times 3 is 9, and 1, you can make 8. So it will be minus 9 plus 1. Yeah, it seems about right to me. Let's move on to part C. Expand and simplify. So once again, not too bad. So multiplying all this by 4x, you get 4x squared plus 12x. Now I always do a bracket because separate them. For the second one, this is just a double bracket, so it's 2x minus 3 times 2x minus 3. Expanding it by 4, so 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. You get another minus 6x, so minus 12x. And a minus 3 times minus 3 is a positive 9. Yeah, so sorry, as I was saying, let me just double check it. So now we just need to subtract the terms. So let me just change color pen. Okay. So you got 4x squared take away 4x. So yeah, you can expand this fully actually. So you got 4x squared plus 12x. And then flipping the sign because you got minus times everything. You get minus 4x squared plus 12x minus 9. Now just tidy up and simplify. So 4x squared take away 4x squared cancels out. 12x plus 12x is a 24x, and you're left with minus 9. So your answer is 24x minus 9. Okay, let's move on. Alright, so Naveed, let's bring it down a bit. So Naveed has 2 bags of tiles, bag A and bag B. There are 10 tiles in bag A, where 7 of these are red and 3 are white. So let me just make a list. So 10 in the bag, 7 red, 3 white. Whereas bag B, so this is A, has 8 tiles. Oh god, that's horrible B. And then what do we have? So 5 are red and 3 are white. Okay, so 5 red, 3 white. So it's always easier to break it down into information like this. So just helps you clarify and organize yourself. So Naveed takes at random one tile from each bag. Work out the probability that tiles are the same color. So what this is trying to say is just pick any two colors which are possible where you can get the same color. So in other words, the only possibilities would be getting either a red or white. And that's it. And to get a red, firstly, it's going to be 7 out of 10 in this bag, and from this bag is 5 out of 8. So this probability will give us 7 out of 10 times 5 over 8. Whereas to get a white from the first bag is 3 out of 10, and the second one is 3 out of 8. Yeah, so 3 out of 10 times 3 out of 8. Let me just do that. And that's it. Now all you have to do is work them out and then just sum them up. So this probability is 7 times 5 is 35 over 80. 3 times 3 is 9. 10 times 8 is 80. And then add them up, you get 44 out of 80. Usually these questions, you don't necessarily need to simplify, but yeah, I think even so, just in case you don't want to get penalized, you can simplify if you really want to. So you get 11 out of 20. So it's also 11 out of 20. Okay. Now, all 18 tiles are put in a box. Naveed takes a random one tile from each of the box. He does not replace the tile. Naveed then takes a random second tile from the box. So now inside the box, he's combined all the values. So let's rewrite the box here, yeah? So we have a box of 18 tiles. And how many red and how many white? So we have 7 red and 5 red separately. So now we've got 12 reds. And of course, this means we're going to have 6 whites. Work out the probability that both tiles are red. So easy. So probability getting red first. And then second tile must be red again. So to get red first, you're gonna have it's gonna be 12 out of 18. So once you've taken a red, now how many are you left with? So now we got exactly 11 reds, and now we have a total of 17. That means the second property is gonna be 11 over 17. And that's it. If you're gonna pick a third tile, then this would be 10 and this would be 16. So now just do the math. So in your calculator, put that in. So 12 over 18 times 8 times 11 over 17 times 17, and you should get 22 over 51. So right, question 16. So we need to solve this quadratic equation as it's set to 0. Okay, so give your solutions correct freezing figures, show you're working clearly. Okay, what this means is that we just need to use a quadratic formula and just solve it. Simple as that. So if you're not sure about the quadratic formula, it's given at the front of the formula sheet, where it's x equals minus a plus minus the square root of b squared minus 4ac over 2a. Okay, where a is the first number here, so a is 2, b is the second part, minus 6, and c is positive 3. Okay, 2 minus 6 and positive 3. So using the formula, x equals minus b, so be minus 6, so positive 6, plus minus the square root of inside b squared minus 6 squared is positive 36, minus 4 times a times c over 2a, which is 4. Now, easy. So, all right, now just put this in a formula and you're done in your calculator. So 6 plus the square root. So first you do the plus answer. I'm going to do 6 plus first. 36 minus 4 times 2 times 3. So this is an easy mark, so we have to make sure we get this, yeah, even me myself. So my first solution using the plus one is 2.37, so round it properly here. And then the negative part is 0. So freezing figure 0.634. 634. Again, make sure you round the last term properly. Okay, and that's it. You have to make sure you get these marks, guys. Yeah. Okay, guys. Question 17. So here the diagram shows a prism. Ooh, 3D trick, isn't it? Triangle PQR. So PQR. So this right angle here has the following dimensions: 20 centimeters across, an angle 30, and across it PM is 12, whereas PQR, this part is a right angle. So this one looks like a typical Pythagoras theorem or 2D trigonometry, the regular trig. Calculate the size of the angle that the line MR, so this one, makes with the plane. Okay. So in these kind of questions, when you want to find an angle to the plane, usually it's always the cross section, so it's always from here. So this is the line. So you always got to think of the diagonal. This helps a lot. So your angle, so your triangle you're really interested in is this part. And this is the angle of interest. Okay, so let me just pull that to the side. So I'm going to make it look a bit like this. So angle alpha, and we know a couple dimensions, I believe. Or do we not know anything? Okay, so yeah, so we need a couple information. So we need to find the length of this part of the base, the length of the height, and the diagonal cross section. This one can be found using 3D Pythagoras. So we can find the length of this a squared, this base squared plus this height squared plus 12 squared. And that could give us our d. To get this height, well, we need the length PQ. And the diagonal cross section, we need this diagonal, this base length here, so we can match it with 12, which is the same here. Okay, so let's have a go. Let's have a go working everything out here then. Okay. So first thing you want to do, so let's work out this length here so we can match it to this length here. I'm going to call this one x. Okay, let's call this one y because we need this length too. So for x, we can use simple 2D trig, so SOHCAHTOA. So at this stage, your trig has to be very good. Okay, it has to be very, and you have to spot things. So we have the opposite way of hypotenuse. So we're looking at so we can say in equation involving x, we can have sine 30 equals opposite over hypotenuse, so x over 20. Therefore, times in 20, x must equal 20 sine 30. Let's just leave that for now. As for y, we need to use trig again, so it'll be adjacent over hypotenuse, because remember this is the angle that's the opposite, and that's going to be ka. So it's going to be the same style, but except this time you'll eventually get 20 cos 30. Okay, so you can use the same formulation, but you'll get these two results. That's perfect. So that means this height here is the same as this height here. So this height is also x, so that's good. Now the diagonal length d, let's call this d, the big diagonal. That's basically y squared plus x squared plus 12 squared will give us a d squared. So let me call that d. So that's going to be d squared equals x squared plus y squared plus 12 squared. We know what x squared and y squared is. It's just the square of these two guys. And we can find the value of d. So let's do that now actually. So this is going to give us, in your calculator, put 20 sine 30 all squared, so bracket 20 sine 30 squared plus, next one, so I'll do it here, 20 sine 30 squared plus 20 cos 30 squared plus 12 squared. Okay, it's going to take some time. 30 squared plus 12 squared. Okay, this gave me 544. Okay, I hope that's okay. Let's just check everything's alright. 20 cos 30. Yep, looks fine to me. And that means d must equal root 544. So I'll just leave it as that, root 544, just to make the equation easy. We also know that this length here is x, so the ml is x, so we can call this one x, which is obviously 20 sine 30. Now that leaves us with this length here, the last diagonal, the last length here. So what is it? So we have oh no, we know this length is 12. That means we can use another 2D Pythagoras to get this length. So this one we know is 12, and this is y. That means this length here, let's call it z. Okay, let's call this length z. This can be calculated using Pythagoras theorem, 2D version. So y squared plus 12 squared equals z squared. Okay, let's do that there. Okay, so let me just do it here. So z squared equals, oh god, I keep forgetting. Y squared plus 12 squared. Okay, squared plus 12 squared. Now, we remember that y squared was 20 cos 30. So 20 cos 30 squared plus 12 squared. What does that give us? So again, in your calculator, there's a lot of working out here, isn't there? Delete. Okay, this gave me 444. Okay, that means z is just root that value. Just keep it as a third, it's easier. Now we're finally getting somewhere. And you know what, let's just put 20 sine 30 as well, just to clear it out. 20 sine 30 was actually 10. This whole time this was 10. Easy value. So that means we're going to have a triangle now, so I'll redraw a triangle here. With alpha here, so this length is 10, this is root 544, root 444. Voila, that means to work this out we need to use the cosine rule now. So yeah, we're getting somewhere, guys, we're getting somewhere. So this means cosine rule time. Okay, let's try this out. So with the cosine rule, we need to label a couple of things. So this one, we have to always label A and the angle A. So the length is always reflective to opposite the angle itself. So the general formula is A squared equals B squared plus C squared minus 2BC cos A. You should find this formula in the beginning of the book. So it's in the formula sheet. Now we'll just pop in all the values. So you go A squared is 100. B squared and C squared, these are these two lengths. Just square them both so you get the whole number. So 544 plus 444 minus 2 times root 544 times root 444 cos alpha. Now let's tidy those up. So all these values here, so what do we get? Okay, so cos alpha is going to equal, okay, so there's a lot of algebra, so it'll be 100 the left hand side minus these two values, so let me add them up. 544 plus 444, which is 988, so minus 988 over, and then let's work out these ones and then divide it across. Minus 2 times root 544. So basically, you guys just make sure you just plug everything and just try and get the result. Okay, you know what? Actually, let's just keep it as is, because I checked on the calculator and you don't get a very nice answer. Okay. Now, once you put in the calculator, you get a certain figure and then you want to cos inverse it. So let's do it. 100 minus 988 to root 544. Oops. 444. Okay. Cos inverse. And voila, I got an answer. I actually got, let me change the color pen. I got, what is it, how many decimal places? I got about 25.388, or 25.4 degrees to 1 dp. Yeah, so, I mean, hopefully this is right, because there's a lot of working out. I'm going to double check the solution, so bear me a second. I like to check. Good news, I got it. So they use a similar step, but they really take the time to work this out. But the answer should be 25.4, and thank God that is the correct answer. So yeah, guys, check exactly what I did and take your time. I mean, the whole idea of this trig question is to really play like a puzzle and make sure you break it into pieces. Yeah. Oof. Honestly, these questions really test your skills in all areas of maths. But yeah, well done. If you got this right, then seriously, you can give yourself a pat on the back because you deserve it. Now, let's move on to the next one. Okay, question 18, guys. I hope you had a nice rest from previous question. Let's have a look. So we're given a Venn diagram which shows the universal set. I should really know what this name is. Let's call it eta for now. And 3 sets, x, y, and z. Okay, so looks like we have a couple intersecting here. Apparently nothing intersects with x, y, and z. These two are unknown. So let me just, I'm going to just guess the question and let's just call this A and B for now because they can't be left empty. The numbers shown represent numbers of elements. So the number of elements that are not in x or not x is 14, or the complement x. So basically here is x and the complement is anything that's outside x. So we're talking about 3, 3, b, and 2. So we can see here that the first statement means 3 plus b plus 2 must equal 14. Therefore b must be, so 3 plus 3 is 6, add 2 is 8. 14 take away 8 should give us 6. Okay, so b is 6 here. Alright, let me just cross that out. and the number elements in Z is 14, so the total in Z is 14. This means A, 0, 3, and 6. A plus 3 plus 6 equals 14. So these two give you 9. That means A must be 5. Okay, cool. So that's good. So let me just make it clean actually, because we might actually need to use it. So 5 and 6. Okay, find the value of the number elements intersecting the union between x and z. So this means the total of x and z. Add up every element. So that's easy. 7, 4, 5, 0, 6, and 3. So I have to keep looking up. 7, 4, so that's 7, 11, 16, 22, and 3, 25. So I got 25 when you add up all these elements. And the number elements intersecting between x and the complement of y. So x firstly is here, and complement y is 7, 5, and 6. So the thing that intersects between all of x and these three numbers, and 2 of course, which obviously would be 7 and y, and 7 and 5. So this would be the intersection between all of x and the complement of x. So 7 plus 5 is 12. Easy, very easy. Okay, so here we're given a vector problem. All right, so what do we know? So we see that AB is parallel to DC. And we know that that DC is actually 2 times bigger than this length. So whatever vector this is, this will be twice as big. So let's get a pen out. So we know that AD firstly is 2b, so it's going in this direction and has a value of 2b. And AB is 4a, that means DC is double, which is 8a. Easy. Oh yeah, I didn't tell you that also M is the midpoint of BC, so this is bang in the center. So wherever BC is, BM is half. So I should write direction of BM equals half the direction of or size of BC. Alright, cool. So find BM in terms of AB, so that's easy. So first things first, find BC, then half of it to get BM. So the value of BC, let's do it. So going from B to C, we need to go back to A, to D, to C. So it'll be negative 4A plus 2B plus 8A. That means tidying this up, minus 4A plus 8A is a plus 4A, and then plus 2B. And that's it. And also BM is half of that. So therefore, BM being half of this is going to give us 2A plus B. Voila. Easy stuff. So that's 2 marks there. Now, N is the point such that DCN is a straight line. So you go D to C and C to N in the ratio of 2 to 1. So let's find DCN. So DCN. So this is 2 to 1 apparently. Yep. So wherever this length is 2 to 1. So this is 8A. That means this is obviously half that length. So this must be 4A as well. Okay. Show that AMN is a straight line. AMN. So A to M to N. So we go find the length A to M and then M to N. So what the idea behind this question is to show that we can find a length AM and the length MN, or at least a combination of them, and that they are directly proportional to each other, meaning that they must have the same vector, but it can be a slightly different size. So it's going to be in terms of either A or B or both, but they must be in terms of each other and proportional to each other. So let's do it. So let's find the vector AM first. That's always easy, and then find MN next. So how do you get from A to M? Well, you just go 4A across to B, and then you add the BM vector, which is this value. So it'll be 4A plus this vector here, which will give us 6A plus B. Easy. Now for MN, what do we have? Let's have a look. Just double check. Yeah, that's cool. So MN. So to go to M to N, well, it's probably easier to go all the way back because we know what BM is. We go back to BM, follow all the way around. Well, actually, you know what? Let's make let's do it that way. So we go from M to B. So this will be the negative quantity. So it'll be minus this quantity, minus 4A plus 2B plus 8A plus 4A. So let's firstly M to N. So what's it going to be? So it'll be minus 2A minus B. So minus 2A plus B. And then it's going to be minus 4a plus 2b. So let's add them up. So minus 4a plus 8a plus 4a will give us a positive 8a plus 2b. So it'll be plus 8a plus 2b. Now let's tidy this up. What do we get? So minus 2a plus 8a is 6a. Minus b plus 2b is plus b. So actually, sometimes you don't have to be direct proportional. You can be identical. So therefore, we can see that this result is also identical to am. So that means that whatever length this vector was, 6a plus b, is also the same here, 6a plus b. Not bad. Not bad. So a to m to n. So this is how you prove it. So you must get something proportional or the same even. So even if the answer was, say, 12a plus 2b, it's still proportional because then you could factorize the 2. So it just means it's 2 times bigger. In this case, they're the same, so it's definitely a straight line. All right, not bad. Let's move on, guys, yeah? Let's move on. Okay, question 20. So the sketch shows the curve with this equation here. So you got a curve equation and the line equation. Okay, so it looks to me that they're intersecting, okay? So they seem to be intersecting at the point A and the point B. And M, as usual, is probably the midpoint, just guessing, yeah? So the line cuts the curve at points A and B. M is the midpoint of AB. Find the coordinates of M. And this is worth, boy, 6 marks. It's really. Okay, let's have a go then. So it shouldn't be too bad. So one thing to note, when you got two equations intersecting, this literally means simultaneous equations, yeah? So keyword, intersecting equations means literally simultaneous equation, yeah? So simultaneous equations. And once you solve the simultaneous equations, you're going to get two pairs of x and y's. Obviously, one's going to be coordinates of A and one's a B. And then you can find this midpoint. So let's do it. So let's intersect these two equations. So intersecting, because they're both thankfully written in terms of y, in terms of x, you can just equate them. Y equals this, y equals that. That means they equal each other. We're going to have x squared plus 4 equals x plus 10. Rewriting as a quadratic, you can move it to the left. Okay, my battery is low. I'll charge in a second. So rewrite as a quadratic, subtract x plus 10 across. You're going to get x squared minus x. 4 take away 10 is minus 6 equals 0. Okay, so now we just need to factorize the problem and find the values of x. So this one seems like, I think, an easy quadratic because there's basic numbers. So to get 6, the products of 6, two numbers to get 6 would be, and has a difference of 1, it has to be 2 and 3, because 2 and 3 make 6, but the difference between 2 and 3 can give you a 1. So we've got x, 2, x, 3. Now to get negative 6 has to be, let's have a look. And to get negative 1 has to be minus 3 plus 2. And that's it. And this tells us straight away that the value of x is negative 2, and the other x is positive 3. That means to find the value of y, you can use any equation. I'll use the easy one, x plus 10. So when x equals negative 2, minus 2 plus 10 is 8. So y equals 8. So this is the first pair. The second pair is when x equals 3, that means x must equal, y must equal 13. So let me write that neatly. Must equal 13. Okay, so we have our two pairs of coordinates. So this one's probably going to be minus 2, 8, and this will be 3, 13. To find the midpoint of these two, you just add the two numbers, two corresponding coordinates, and then divide it by 2 to get the number bang in the middle. You can think of the midpoint as the average of two coordinates. That's how I see it, as the average. So using the mean equation. So we can say that coordinates of A is minus 2, 8. Coordinates of B is 3, 13. The coordinates of M would be the sum of minus 2 and 3 over 2. So minus 2 plus 3 over 2. And the coordinates of, the y coordinate of M would be the sum of 8 and 13 over 2. This should mean, so minus 2 plus 3 is 1. So it'll be 1 over 2 is 0.5. 8 plus 13 is 21, and then half of 21 is, in my head, 10.5. Let me just double check that. I think it is, but double check it. Yep, 10.5. So that means this is your midpoint. So very easy for 6 marks, I believe. As long as you understood that they're intersecting, you find the cones and then you can find the midpoint. It's really all there is, honestly. Okay, and to double check it, if you plug in 0.5 into the x coordinate to get this, because it's on the line, you should get 0.5 plus 10, 10.5. Yep, it's fine. Seems good to me. Let's move on to 21, guys. And here we are, guys. I think we are at the final question of the day. Okay. See, this one's really interesting because this ones look like a pair of parametric equations, and this is something you don't really see until A-level maths. So what do we have here? So we got y equals at squared minus 2at, and we got x equals 2a root t. Alright, so let's have it, just absorb that quickly. Now express y in terms of x and a. Okay, so notice how they omitted the t. This is telling me that we need to get rid of the t, or at least substitute. So we need to make equation in terms of x and y. So we need to make t the subject of x, of the second equation, and then pop into the first. So then you'll notice that the t's will vanish. We're just going to have an equation in terms of x and a, with y being the subject. So let's try it out. So, and then once you do that, you have to give your answers in this term. So yeah, all these other letters, P, Q, M, and N, are just numbers, just integers. So let's try that out. So the first step is to rewrite the second equation in terms of t. To do that, we can divide 2a across. We have x over 2a equals root t, and then square both sides. So we've got x over 2a squared equals t. And to make it tidy, I guess, if you actually square it, you get x squared over, and then 2a squared is 4a squared. So make sure you square every single term. Okay, now we have this term here, so let me just move it to the side. Now we can pop this t into the very first equation. So changing the color of my pen to blue, we can say that now y equals a times, so t squared, oh yeah, I should get an expression for t squared as well. So t squared is going to be the square of everything here. So we're going to have x to the power 4, and squaring the bottom fraction, we're going to get 16a to the power 4. So now t squared is going to be a times this one, so times x to the power 4 over 16a power 4 minus, and then the second part 2at, 2 times a times t, which is, just put bracket, x squared over 4a squared. Okay, alright, let's take a breather here a second, yeah? So now all we want to do is just tidy up this fraction and make it look like this. So far it kind of looks similar, except there's no a's anymore on the top line. Let's just sort this out. So combining this, let's have a look. We should have this. So a times x to the power 4, so you can have ax to the power 4 over 16a to the power 4 minus 2a times this would be 2ax squared over 4a squared. So basically you just stick the term on the top line for both of them, so they both go here. So that's how it works. A whole number times a fraction is multiplied to the top only. Now for these final terms here, you would want to try and simplify the problem if possible. So you notice how you got a's on both sides. We can try and cut it down. So cancelling down, 1a disappears, so this a4 becomes an a cubed. Cancelling this a, made this a squared into a single a. Now 2 divided by 4, well, divide them both by 2, this cancels, becomes a 1, and this becomes a 2. So this means what we're left with. So we've got x to the power 4 over 16a cubed. Now this part here, 1 times x squared is x squared, and then 2 times a to the power 1 is just 2a. So let's put this even more neater, because now it just looks like there's too many things going on. So we've got x to the power 4 over 16a cubed minus x squared over 2a. All right. Oh, cool, man. So let's have a look at the final expression. So give your answer in this form. Hey, it looks like we did it. So we got P, which represents 4, Q, which represents 2, M is 16 and 3, which is there, and N is finally 2. So we can say therefore, let me just put the letters next to it. We can say therefore P equals 4 here, Q equals 2, the next one M equals 16, and N equals 2. And that's it. I think we're done. That's the end of the paper. So if you guys have been following through all the way to the end, then give yourself, a pat on the back, and thank you for watching. And let me know if, give me any feedback at the bottom. Let me know if my voice is too low, or there's anything you don't understand, or some questions are done too fast. All this feedback is good, so it can actually help me make better videos next time. Right now I'm just working on papers that have been officially released, well, most of the time, by Edexcel. So